Today, on how it's made. Fishing reels. Answering a casting call. Miniature houses. Model homes for the young and the young at heart. And mixers. We'll bring you a stirring story from the factory in a special 2-part report. The Chinese in the 12th century were the first to wind excess fishing line on their rods before unreeling it back into the water. Today's reels have gears to quickly deploy and retrieve the line. They're made with lightweight, high-strength materials, so you can catch bigger, stronger fish, or at least try to. Antique reels are heavy and have just one speed. Modern reels have 2 speeds and fewer parts. To make a reel's frame, a computer-guided router cuts 4 openings in a cylinder made of aluminum. These let the angler, the person fishing, access the spool inside the frame to undo any knots in the line. Another cutting machine shapes a stainless steel blank into a spindle, the inner part of the reel around which the fishing line winds. It also carves 2 pinion gears into the piece. The high gear retrieves line faster, the low gear gives more power to fight big fish. The machine's cutters are made of carbide, an extremely durable material. Even so, workers change them weekly. Another cutter carves the reel's main gears, a high speed and a low speed. These main gears interact with the pinion gears to make the spool revolve. This lets the angler wind line back onto the reel. This cutter drills small indentations, part of the reel's drag system, which lets the angler adjust line tension to fight large fish. The next cutter engraves the company name into one of the reel's 2 side plates. Yet another cutter engraves the drag settings, 1 through 4, and then strike. Strike lets the angler fight fish weighing up to 900 kilos. Next, a process called anodizing. The side plates are dipped in a series of chemical baths that bind a gold-colored dye to their surface. Now, time to assemble the fishing reel. First, they apply waterproof grease and lubricant to 2 safety catches that prevent an angler from applying too little or too much line tension. A worker then adds a bearing to support the spindle in the spool. He also installs what's called a click plate that makes clicking sounds when a fish takes the line. He adds a stainless steel spindle sleeve and drag plate, and a sturdy synthetic washer. He then adds the spindle and pinion gears to the spool. The spool is now ready to go into the frame. Using a rotating clamp to steady the reel, another worker installs a stainless steel fixture that attaches the reel to the rod. Then installs the left side plate with 6 screws. This metal spring and plunger enable the angler to change speeds from high to low with just the push of a button. A metal clip locks the mechanism in place. A little grease to the gearing, then a plastic cover, and the spool is fully assembled. He inserts it in the frame and installs a harness lug used to attach the reel to what's called a fighting harness, worn to prevent a fish from yanking the rod out of your hands. Now the worker mounts the right side plate. He adds a lever and a knob to adjust the drag settings. You turn the knob clockwise for more tension, counterclockwise for less. Next, he installs the stainless steel and plastic knob you use to reel in the line. And finally, the button for switching speeds. He tests the drag lever and the gears to check if they engage properly. He puts it into high speed to see if the safety catch prevents what's called free spooling, a glitch that could send 900 meters of line flying wildly out of control and leave you reeling. For hundreds of years, doll houses have been hot property. At first, they were built to entertain the children of the wealthy, but eventually, mass production made these mini mansions widely available, and they continue to be great places for childhood fantasies to reside. Any home building project is all about the details. But the details don't get much smaller than this. These doll houses are miniature versions of actual homes, made to scale. They take a big sheet of plywood and slice it into smaller pieces. For a consistently accurate job, they use a saw guide, which positions the wood for a specific cut. There's a different guide for each dollhouse part. Using a hot iron, they brand the company name onto a foundation part. This dollhouse will be sold as a kit, and here they demonstrate how to put it together. Back on the production line, they're milling the siding. This machine cuts furrows in wood panels to mimic a clapboard finish. Next, using a router, they cut window and door holes. And now the walls go up. Because this is a kit, each piece has to be a perfect fit because, unlike a real construction project, they can't do recuts on site. They install the second floor and tape it with ordinary masking tape while the glue dries. And now for the second story. It can take up to 100 hours to paint and assemble all the parts in a dollhouse kit, depending on how elaborate the design is. Next, they raise the roof. This Victorian design has a two-part roof with a tower in the middle. They add weight to apply pressure while the glue dries. This machine's protective cover has been temporarily removed to show its inner workings. They carefully feed in a piece of pine. It cuts the board into little shingles, which fall into a bin below. Once the shingles are stained, they hot glue them to the roof, following a grid that was penciled on in advance. They wrap the roof with tape to stabilize it while the glue dries. Back in the factory, 4 cutting wheels shape a piece of pine into moldings that will be used for trim on various models. The door now goes on. It's been trimmed with some of the molding we just saw being made. The windows also have some molding details. All this trim has been made on the same machine, using different cutters for the different profiles. This railing is a nice touch, and it will also provide support for the structure. All that's left is the interior decorating. Some people spend a small fortune on this stuff. Tiny toilets, chairs, even full kitchens in miniature. And in this model of President Lincoln's home, the details are historically accurate. Now they carefully pack up all the pieces. Soon they'll make some child's dream of home ownership come true. But first, somebody had better read the instructions. Whipping up a dessert used to take a fair bit of muscle power until they invented a mixer with a motor in the early part of the 20th century. The first ones were very industrial looking and not much like today's sleek models. But with this invention, the job of pastry making has become a piece of cake. Today's mixers can whisk you into a world of the culinary arts. To make one, a machine straightens wire between a row of wheels. Computer-programmed forming tools make a total of a dozen bends to produce arc shapes, which will be used to build a whip attachment for the mixer. To assemble a whip, a technician fits the wire arcs into an aluminum hub, starting with the largest one and graduating down to the smallest. Underneath, a punch mechanism dimples the hub to fasten each wire to it. Here, they drop some dough hooks and beaters into a vibrating bowl full of metal nuggets. The friction polishes these zinc mixer attachments and gets rid of the sharp edges. Next, they thread a band of aluminum into a machine that bends it to the contour of the mixer. It's a piece of trim that carries the brand name. A bowl feeder now funnels hollow iron weights towards a system that threads wire through each of them. Mechanical arms pinch and bend the wire, making little hooks on the ends. 2 of these weights will be used in each speed governor, a device which keeps the mixer's speed constant despite changes in the load. To assemble the speed governor, they arrange a brass hub, spring, and a washer in a holding device, and then press fit them together. They attach the 2 weights to the spring assembly using the protruding wires. The speed governor system is now complete. Here's how the governor weights fly out to regulate the mixer's speed. And now it's time to prepare the motor shaft. They lower the spinning steel cylinder to a revolving cutter. Lubricant keeps the cutter cool as it carves spirals into the end of the shaft. The spiraling grooves will allow the shaft to drive the mixer's internal gears. They install the shaft, with motor windings and bearings attached, into the mixer body. Next, they rivet electrical contacts to plastic control boards. These contacts will convey electricity to drive the motor. They deliver an electrical charge to the contacts to make sure they're working. Then they attach screws, nuts, and springs to complete the control board assembly. The control board will work in concert with the governor weights to control the mixer's speed. For these mixers to really shine, they'll need a good paint job. To prepare the mixer parts for painting, they polish them on an abrasive belt. Then it's into the paint booth. This is a highly charged process. The paint has a positive electrical charge and is attracted to the zinc mixer parts, which are negatively charged. Now all the parts are in the mix. Coming up next, we'll show you how they all come together. Behind many a successful cook is a well-oiled machine that's made for speed, and that's the electric mixer. It produces the best results when the blades turn rapidly. If they turn too slowly, they won't mix the batter thoroughly, and that means your pastry could be a flop. To assemble this tilt-head mixer, they install a gear to drive the attachments. Next comes the stator, which creates the electrical field for the motor. A dab of oil, and then they mount the shaft and motor windings inside the unit. They slide 2 motor brushes into pre-drilled holes. The motor brush will supply electricity to the internal components. This bearing bracket holds the motor in place. They lubricate the front of it before installing the electrical control board. They wrap a trim band with the brand name on it around the outside. Next, they pour gobs of grease into the section of the mixer that will hold the gears. The gear section will be sealed, so the grease can't leak out. They attach the other half of the unit that has some gears already fixed to it. They insert a drive pin in the shaft that moves the whisk and other attachments, and screw the 2 halves together. They apply more grease to this section, and then install the planetary gear. This gear will rotate the mixer attachments around the bowl. With a mallet, the worker hammers a pin to attach the planetary gear. He taps a decorative ring onto the outside. He mounts the motor unit to the base and marks an identification number onto the bottom. Now they take the tilt-head mixer for a spin. And the next step is to adjust the speed. The technician installs a speed-setting tool in the hub of the mixer. While the gears turn, he checks the readout and tunes it up. Each mixer has to be able to make a dizzying 200 rotations per minute. They cap the hub. The final step is testing the beater. They check that it's correctly positioned above the bowl. One last polish, and it's ready. Over at another station, they're making a more commercial type of mixer, one with a bowl that lifts to the beater instead of a tilt head that lowers to the bowl. They screw a base to a bowl support piece. Then they attach the lower housing for the beater motor. As the mixer moves on a conveyor, they install the motor and gears. They add a generous squirt of grease to lubricate the transmission, and then encase the top of the motor with more housing. Continuing down the line, they install the electrical speed controls, topping it off with more housing. They wrap the signature piece of trim around it. Using a probe, they check the wattage and speed. It passes inspection, and it's ready for packing. It's taken approximately 10 minutes to assemble this bowl lift mixer, but it's made to last a lifetime. And with such a range of attachments for these mixers, you can really go stir crazy.